Okay, now let's look at the word problems that involve inequalities. Okay, so first of all, let's look at the example. The width of a rectangle is W centimeters and the length is 4 centimeters longer than the width. If the perimeter is less than or equal to 28 centimeters, find the largest value of W. Okay. So let me highlight less than or equal to. Okay. So by now, we should know the difference between less than and less than or equal to, bigger than and bigger than or equal to. Okay, so these four statements or these four group of words mean different things. Okay, I will repeat this because this is very important. So when we say less than, if we only say less than, that means this. Okay, if we say less than or equal to, then we're talking about this sign. Okay, bigger than or larger than, we usually say bigger than. If we only say bigger than, it's this one. If we say bigger than or equal to, then we're talking about this sign. Okay, so this is very important. We need to know that these four statements or these four signs mean different things. Okay, so the question defined W for us. Okay, so let's just draw a diagram so it can help us understand what the question is really asking. So let's say we have a rectangle here. Okay, it says the width of a rectangle is W centimeters. So the width here, this is W, right? This is also W. They're both width, right? And the length is 4 meters, sorry, 4 centimeters longer than the width. Since the width is W centimeters, the length should be W plus 4 centimeters. So the length right? The unit is centimeters, right? Now we know that the perimeter of the rectangle is less than or equal to 28 centimeters. We know how to find the perimeter of a rectangle, right? The perimeter of a rectangle is equal to 2 times the length plus the width, right? Because we have, this is width, this is also width, right? This is length, this is also length, right? So we have 2 widths and 2 lengths. When we calculate the perimeter of a rectangle, this is a formula, right? 2 times length plus width. And we know that this is smaller than or equal to 28 centimeters. So now let's plug in these. Okay. I'll move this a little bit so we have more space. Okay. So the perimeter of the rectangle is smaller than or equal to 28 centimeters. So 2 times the width is just width, W, right? Because we define, the question defined it for us. The width of the rectangle is W centimeters. And the length is W plus 4, right? So this is the length. Okay, so 2 times W plus 4. This expression represents the perimeter of the rectangle in this question. And the question says the perimeter of the rectangle is smaller than or equal to 28. So this is the inequality that we should write based on the information given in this question. Okay, solving this inequality is not the hard part because we can see the numbers are very straightforward, right? There's no negative, there's no fraction. It's very easy. The hard part here is to write this inequality accurately based on the information given in this question. Okay, so let's just quickly solve this. So 2 times W plus W, that's 2W, right? 2W plus 4, smaller than or equal to 28. Okay. Now you have two ways of doing this. The first way, you can divide 2 on both sides of the equation. So you can divide the whole thing by 2 and divide this side by 2 as well to get rid of this coefficient. But here, let's solve it in the traditional way. Let's use the distributive property so we can review a little bit too. So let's use the distributive property. Okay, distributive property. 2 times 2W, that's 4W. Right? I also need to multiply 2 by 4. 2 times 4, that's 8. Smaller than or equal to 28. This should be straightforward by now, right? We subtract 8 from both sides of the inequality. 4W plus 8, subtract 8. And since this is not multiply or divide a negative number to both sides of the equation, the sign doesn't change. It stays the same, smaller than or equal to 28 minus 8, right? Because this side, you subtract 8 from the left-hand side of the inequality. In order to keep the inequality relatively the same, you need to subtract 8 from the right-hand side as well. Okay? So the left-hand side, it becomes 4W, right? Smaller than or equal to 28 minus 8, that's 20. And the solution is W is smaller than or equal to 5 centimeters. Okay, so this is our solution. This is our solution. Okay, so this is how we solve this example question. Okay, we gather all the information given in this question, and we try to write an inequality based on the information in this question. And then we solve the inequality in order to get the solution. Okay, so these are the steps that we use to solve this kind of word problems. Okay, let's move on to the first class practice. Okay, question 1, it says 5 times y is less than or equal to. This is another less than or equal to example. Okay, so we've seen multiple examples that involve less than or equal to. Okay, let's try to remember how to deal with it. Okay, so 5 times y is less than or equal to the sum of y and 5. This is very straightforward, right? Because the sentence, like the first sentence, basically wrote the inequality for us, right? This is very straightforward. 5 times y, that's 5y, right? 5 times y, that's 5y, is less than or equal to, the sum of y and 5. That means y plus 5, right? So the inequality basically wrote itself and find the range of the possible value of y. So this is the inequality that we need to write. And now our job is to solve it. Okay. How to solve it? How to solve it? We use the same property. Okay, we use the same property. Remember what I said in class and in the last video. I said solving inequalities is very, very similar to solving equations, right? We move all the unknowns to one side of the inequality, and we leave all the numbers to the other side of the inequality. It's the same here, right? Imagine if this was an equation, how would you solve it? You would move this y to this side and change the sign. Or you can think of it as you subtract y from both sides of the inequality. So here you can treat y as a real number, right? Because y technically is a real number. Y represents some kind of real number. You just don't know what it is, right? But after all, it's a real number. So here you can subtract y from both sides of the equation. So 5y minus y, and the sign doesn't change because we're not multiplying or dividing a negative number to both sides of the inequality. The sign doesn't change. The right hand side, y plus 5, also we need to minus y here because we subtract y here, we need to do the same to the other side of the inequality. Okay, 5y minus y, that's 4y. Sign doesn't change. This y, they canceled out, right? And only 5 is left. Here, we divide 4 to both sides of the inequality. 4y divided by 4, so we can get rid of the coefficient. And here, we're not dividing a negative number, we're dividing a positive number, so the sign doesn't change, right? Sign doesn't change. 5/4. Okay. When you multiply or divide or subtract or add any number, you need to do the same to both sides. Otherwise, the inequality wouldn't hold anymore, right? For example, I will just take a very simple example. Let's say 1 is smaller than 2. This is obvious, right? If I want to add a real number, then I need to add a real number to both sides of the inequality. Let's say 1 plus 1, 2 plus 1. It's still smaller than, right? So 1 plus 1 is still smaller than 2 plus 1. You can only add 1 to one side of the equation because it might not hold anymore. For example, if you only add 1 to left side of the equation, then this inequality doesn't hold anymore because 1 plus 1 is not smaller than 2, it's equal to 2. So the point here is when you add, subtract, multiply, or divide any number to this inequality, you need to do that to both sides. This is very important. Please remember this. So here, 4 and 4 cancels out. Y is smaller than or equal to 5/4. Okay, so this is the solution. This is the solution. So the possible values of y are less equal than. The less equal than is the same as less than or equal to 5/4. So this is question 1. Question 2. David has 22 coins. Each coin is either a $1 coin or a $2 coin. Okay. The total value of the coin is more than $23. Find the maximum number of $1 coin that David has. Okay. So now David has 22 coins. Some of the coins are $1. Some of the coins are $2. We don't know how many $1 or how many $2 he has, right? But we know that the total value of the coins is more than $23. So here, let's define the number of $1 coins to be X. So let's assume that David has X $1 coins. We know that he only has 22 coins. Some of them are $1 coins. Some of them are $2 coins. Now that we assume he has X $1 coins, how many $2 coins does it have? It should be 22 minus X. Then the number of $2 coins is 22 minus X, right? And we know that each $1 coin represents $1. Each $2 coins represents $2. And the question says, the total value of the coins is more than $23, right? So X $1 coins, so the value of X $1 coins plus the value of 22 minus X $2 coins is more than $23. How do we write this inequality? How do we express the value of X $1? the value of X $1. So we have X $1. Each of the coin represents $1. So this is the value of X $1 coins. Plus, how do we represent the value of 22 minus X $2 coins? We have 22 minus X coins. Each coin represents $2. So the value should be 22 minus X times 2. Right? So this expression represents the total value of X1 coins and 22 minus X2 coins. And we know that the total value of the coins is more than $23 because this is given in this question. That means the value of the coins is more than $23. Okay. So like I said in, I don't know, like 5-6 minutes ago, when it comes to word problems, solving the inequality is never the hardest part. Okay, it's not the same as like if the question asked you to solve some kind of inequalities, because in those questions, the inequalities might be quite complicated, right? They might involve negative coefficients where you need to flip the signs, or they might give you some kind of fractions, so you need to multiply some numbers to get rid of the denominators of the fractions. When it comes to word problems, solving the inequality is never the most difficult part. Writing the inequality that fits the information given in this question is indeed the hardest part. Okay, you need to fully understand what the question is asking you. You need to understand the relationship between all the numbers, all the variables, okay, all the information. And then you need to connect all the information with one expression, okay? And then you solve that inequality. But like I said, that part is never the hardest part, okay? And usually, like when you solve a word problem, if you have the inequality, if you have the correct inequality, then you already got most of the marks. Because for word problems, the focus, the emphasis is on whether you can get all the information and write the correct inequality instead of testing your skills of actually solving the inequalities. Okay, so this is the inequality that we should write based on the information in this question. Okay, so this is the inequality. Let's quickly solve it. So x times 1, that's just x. Right, so this is x plus here distributive rule, right? It doesn't matter if 2 is in front of the bracket or after the bracket. It's you need to recognize this. This is still distributive rule, right? You need to time 22 and then time x. Okay. So 22 times 2, that's 44. Minus 2 times x, that's 2x. Greater than 23. Okay. And x minus 2x, that's minus x, right? And here we subtract 44 from both sides of the inequality, right? So plus 44 minus 44. greater than 23 minus 44, right? And this becomes 0. Minus x greater than 21. Right? Minus 21. Yeah. And here, in order to get rid of the negative inequality, sorry, in order to get rid of the negative coefficient, we need to divide minus 1 to both sides of the inequality. Right? So I'll write it here. Minus x divided by minus 1. Here, we need to flip the sign because we're dividing a negative number to both sides of the inequality. Minus 21 over minus 1. So this becomes x is equal, x is smaller than 21. Okay. That means if the total value of the coins wants to be more than 23, the maximum number of $1 coins cannot be bigger than 21. Okay. So this is the solution. Okay. Not only do you need to find the solution, you also need to understand the meaning of the solution. Okay. Here, we already defined here, right? We assume that David has X $1 coins. And here, X is smaller than 21. These two pieces of information are consistent. Okay, this means David cannot have more than 21 $1 coins if the total value of the coins is more than $23. Okay, so here, solution, the maximum number of $1 coins that David has is sorry guys, I just read the question again. Here, it shouldn't be 21. So the final solution, it should be 20. This is, yeah, it's very easy to make a mistake here. The solution that we found here is x is strictly less than 21, right? That means 21, the boundary point, is not part of the solution, okay? And since x represents the number of coins, x can only be integers, right? So x is smaller than 21 and x needs to be integer. So the one integer that's smaller than 21 is 20. So here, the solution should be 20, not 21. Okay. If you want to if you want to check it, it's very easy to check as well. I will use a different number. I'll use a different color. So the maximum number of $1 is 20, right? So if David has 20, so if he has $21, we know that he has 22 coins in total, right? If he has $21, that means he only has $2. That will be 20 plus 4, which is $24, right? And 24 is bigger than 23, right? So we know that 20 is right. Let's try 21. If David has 21 $1 coins. If David has 21 $1 coins, that means he only has one $2, right? Plus one $2. This way, he only has 21 times 1, which is 21, plus 2 times 1 is 2, $23. Okay, but this is not consistent with the question, because the question says the total value of the coin is more than $23. It didn't say it can be $23. The question says the value has to be more than $23, which means this solution, this is not correct. Okay, which means 21 is not acceptable. This is wrong. Okay, X, the maximum number of $1 coins can only be 20, not 21. Okay, so this is everything that we need to cover for week 11. Yeah, let me know if you have any further questions. Okay.